Hi, welcome back to the Quantitative Sustainable Design for Sanitation and Resource Recovery Systems, or better known as QSDsan tutorials. My name is Tori Morgan, and I'm a postdoctoral research associate working in the QSD group. And in this video, I'll show you how to run a lifecycle assessment with QSDsan. So let's go to the QSDsan Read the Docs page and fire up our Jupyter Notebook to get started. On the Read the Docs QSDsan page, we will choose Lifecycle Assessment, or LCA for short. This tutorial is prepared by Yao-Lin Lee, and in it we will cover the ImpactIndicator class, how to add impact items and stream impact items, how to account for construction, transportation, and other activities in our LCA, and how to perform a life cycle assessment in QSDsan. So as always, we first need to import QSDsan and check our version history. So we can just copy this line if we want. Cool. So at the time this tutorial was made, it was made with version 3.9. At the time of recording this video, I'm using the 10th version 3.10 of QSDsan. So one thing to note is LCA is similar to a TA or techno-economic analysis, but a little more complicated with multiple indicators to choose from, such as global warming potential or fossil fuel energy consumption. And we can view life cycle assessment results for those multiple indicators. So QSDsan implements multiple new classes for LCA. And the first one to start with is the ImpactIndicator class. Let's see what the ImpactIndicator class needs. So we can use this method to see what we need. So we first need to give it an ID and specify the units. We can also give it an alias if we want, and a method and category, but this is just for our own reference. It won't be used anywhere in the code, so it's not that important. So an alias is for convenience, method and category is for our own reference, and then ID is important to reference the item, and then unit is important because QSDsan can do unit conversions with these impact items. For example, we might want to evaluate the kilogram equivalent of carbon dioxide per kilogram of steel, but earlier on, maybe you used grams of steel somewhere. So it'll convert that for you. So it's very important that we have the units. We're going to look at global warming potential and fossil fuel energy consumption. So we can create these two together. See what this code has. So it has the ID that we need to set, and we're setting as global warming. Remember, you don't need to do method and category, but we're going to add it here anyways. And there's a description. And then most importantly, our unit is in kilogram. For the fossil fuel energy consumption, we have an alias, which is FEC. Our unit is megajoules. So let's see what that looks like. First, we're going to be looking at the global warming potential. So it has, does not have an alias, but its ID is global warming, and the units are kilogram carbon dioxide equivalent. Now, we didn't assign an alias, but we can always assign that later by doing GWP. GWP dot alias. And then we can see how that looks different by using that show method again. So now we have the ID, we have the unit, we have an alias, we defined our method and categories just for our own reference, and a little description of this impact indicator. Let's see what our fossil fuel energy consumption looks like. So for this one, maybe we got really lazy. We don't really care what the method or category is. We just made sure to do the ID and the unit, but we did assign the alias right here and put FEC. And we could assign the method later. So you could do FEC dot method and then tools. Oops. Let's see if that works. And let's do FEC.show. Yeah. Okay, so similar to how we assigned our alias later, we can also do the same thing with our other attributes in this class, or for the impact indicator. So we can also retrieve an impact indicator through its ID or alias. So for example, here, so sorry, I don't know, my hands are loose today. So here we use the alias in order to get our impact indicator for fossil fuel energy consumption. And then we can also look at all of our defined impact indicators. So the two indicators we created, we would be able to see them by using this method. And here's our global warming and our fossil energy consumption. Now that we have impact indicators, we can add impact items and specify the environmental impacts for each function of the item. Impact items are used more for construction, transportation, and electricity, and then stream impacts are more for looking at chemicals similar to the waste stream. Everything an impact item can do, a stream impact item can do, but it's more related to streams in the system. So let's first look at impact item. And we're going to try an example where we assume we need some electricity that's going to generate 1 kilowatt hour of electricity with 0.15 kilograms of carbon dioxide emitted, and it uses 4,500 kilojoules of fossil energy. So let's see what an impact item looks like. So similar to the impact indicator, we need to give it an ID and the functional unit. There is also a price. For example, if we have concrete, we can set the price of concrete, but costs for certain chemicals should be set in the waste stream. And then we have source in case we have multiple types of concrete or multiple types of steel, and we want to keep track of all of those that might have different impacts associated with them. And so we can assign this later. So from our example, we're going to set electricity as an impact item. So we have our ID, that's important, and our functional unit. And then we can see what that looks like. So again, we have our impact item, that's electricity, and it shows it in kilowatt hour. And we did not set a price for this item. So here's a note that just elaborates more on what I was talking about with price earlier. So impact item also has a price attribute that allows you to put in the price for the impact, but it's mostly used for construction items that will be used in the capital cost. If you want to account for the cost of electricity, you should set the power utility usage of the unit and modify the biosteam.powerutility.price. So now we can add characterization factors for our two indicators. So we can start with our global warming potential. And let's see, so we have electricity again, and then the global warming potential. We're using 0.25, so we gave it the impact indicator. and the amount for that. And so we have that now. Let's see, we can also do the same for the fossil energy consumption. And we can also specify if we're using different units than what QSDsan is using, and the QSDsan will do that unit conversion for us. So here we know we're using 4,500 kilojoules. Say we're a little lazy and we don't want to do that unit conversion. QSDsan is really sweet because it will do that conversion for us. So we see here it was in kilojoules and now it's in megajoules and did that conversion for us. So if we want to change the value, we can also do that. So it looks like we're changing it from maybe 4,500 to 50. And this time we didn't specify that the units were in kilojoules, so it didn't need to do a conversion. It just kept it in megajoules. And then similar to ImpactIndicator, we can also retrieve one impact item or all of our impact items. And it's important that you use this get_item method to get a specific item, and get_all_items if you want to see all of your impact items. So we have our electricity, and we have the global warming potential impact and the fossil energy consumption impact. So now we can look at the stream impact item. So a special case of impact items are ones related to material inputs and generated waste/emissions. And it's more convenient to use stream impact item, which is a subclass of an impact item. And a big perk of using a stream impact item is that you can link it to a particular stream. So after you simulate the system, the quantity of this item will be automatically updated. So let's show an example of this by setting some default components. So we're going to load default components. And we're going to create a wastewater stream. So let's say that we want to count for emissions, our global warming potential, and our fuel energy consumption. So we have our, we need to put our link stream, which is wastewater that we created, the global warming potential, and then the fossil energy consumption. Again, we're specifying a different unit so that QSDsan can do the conversion. So we have 100 kilojoules, and it'll convert that to megajoules for us. So you see here, it's linked to wastewater 1, and we don't have a price for it, but we have our global warming and then our fossil energy consumption. And it was converted from the 100 kilojoules to now 0.1 megajoules. So the price of the impact item will be linked to the price of the stream, and we can create that similar to how we were creating the methods and aliases later on, as we showed earlier. So let's do the price, or put in the price, 0.2, and show. So now we have our stream impact item. It's linked to wastewater 1, and it has a price with those previous global warming and fossil energy consumption impacts. So now in designing a system, we may need multiple items of the same settings. So you can have multiple wastewater streams, and we can use the copy method that we've talked about in our previous tutorials in order to set as source. the original impact item as the source. So we can do that here. So now we have wastewater 2. So before, I think the flow was 100. Yeah, 1,000. And now we have a wastewater stream with a different flow. And we want to create a copy. And then see what that wastewater item 2 would look like. So see, we didn't input any of those characterization factors like we did earlier, but because we copied it, it copied it to this wastewater item. So it copied wastewater item into wastewater item 2. And the only difference will be our flow. And then we can update the characterization factor values of either the impact items that would affect both. So let's look at fossil energy consumption. We can update that. And see how it affects wastewater item and wastewater item 2. So you see how it affects both of the wastewater items now. And this works for impact item objects other than stream impacts as well. So for electricity, we could copy from earlier and see what the copy looks like. And even shows that it is a copy by saying copied electricity, because that's the ID we gave it here. And it has the same characterization factors as we set previously. So now we can move on to the third section of this module, which is going over construction and transportation classes. So the construction class is used to include impacts associated with the construction of a certain unit operation and is stored in the SAN unit.construction. So for example, we can go over a system that has a pit latrine with several construction activities and show for illustration purposes, because pit latrine requires setting multiple influence. Let's just check the established unit systems. And you can find this in the QSDsan folder on GitHub if you want to access it. Oops. Okay, so we're going to import this system as BW from GitHub. And we're going to look at what are the items for construction for this system. So now we have a list of construction items that are associated with our system. The first one is cement, sand, gravel, brick, liner, steel, wood, and excavation. So let's say we want to look at the first one, which is cement. And we want to name it so that we can identify it without having to type bw.a2.construction and the number that is associated with the item. So we can do cement equals bw.a2.construction and then 0, because remember in Python, everything starts with 0. So this would be 0, 1, 2, so on and so forth. So we see that we have cement, and that's our impact item. This is the item and the construction class. It does not have associated lifetime. It does have a quantity. It does not have a cost. And then we have associated global warming impacts for cement. So each construction activity is linked with an impact item. So we can look at cement item, and we can see the characterization factor associated with cement. And then the total impact and cost is calculated through the quantity of the activity and the price, or the characterization factor is shown here of the impact item. So if we type cement.quantity, this is how much cement that we are using. And then if we want to look at the global warming impacts and find the total global warming impacts, remember this is just the characterization factor. It's not the total global warming impact of the cement that we are using. We have to multiply that by the quantity of cement that we are using. So let me try, no. Let's see if I probably will get an error for my laziness. So cement.impacts, see if that works. And it worked. So now we have our cement is set in our life cycle assessment for when we run it later on. So similar to construction, we also have transportation object that is linked to an impact item. However, it calculates the total impacts by taking to the transportation load, distance, and interval. So before, the construction was taking into account the quantity, and then now, and also, maybe replacement, things like that, but transportation is looking at how much it weighs, the distance has to go, and an interval. So if we want to calculate the impacts associated with cars, we can create that item or make an impact item for this. So we have our car item, here's our ID, and then here's our functional unit that we need. And we're setting it that has a global warming potential of 10. We didn't assign any units to that. Well, we have the functional unit right here. So let's see what that looks like. So we have our car item, the functional unit that is using, and the characterization factor associated with the global warming for this item. Then to add the activity, we will see what this code looks like. So now we have car transportation, or car trans for short. And so we do, you saw here when we were creating the item, it's impact item. Here we're creating or using the transportation class. So it's qs.transportation. Our item is still car item. Our load type is a mass. We have how much we're loading, the distance, our unit, and the interval. And looks like Yao-Lin used a different interval for fun. Just want to check that interval one more time, if it will let me. Oh, 20, okay. Let's see. And also it's probably good to always show and make sure that you're inputting the units correctly, because maybe you forgot that load is in a different unit other than kilograms, and you were thinking it was grams or something like that. So here's where you can just double check and make sure that all of your units were the units that you were thinking of using and are the correct units. And then you have your impact right here. So Yellen is noting that here the impacts are calculated for each trip, and the life cycle assessment. QSDsan will calculate how many trips are made in the entire lifetime of the system using interval. So that interval that you were setting will say how many trips for the lifetime of the system. Now let's see. So in a SAN unit, transportation activities are stored in SAN unit.transportation. So let's see what transportation activities we're storing. So we only have one here, and that's total truck. And since we only have one, we can only look at this one. So we can do bw.a3.transportation0. Remember, if you are using this later on and you just want a short way of doing it, you could set that maybe truck transportation equals that. But since we're not using it more than once here, I'll go back to the original code and show that. So here's your impact item, the load associated with it, the distance, the interval, and then the total impacts. So if there are additional activities that are not covered by materials, construction, and transportation, then you can add it when making the LCA object, for example, in the LCA section below that we'll be going over. Now we can finally use the LCA class to perform a life cycle assessment. So like techno-economic analysis, each instance of LCA is linked with a system object. So we can create that system and see what that system might look like. So we have our excretion, with toilet paper, flushing water, cleansing water, and desiccant coming into our pit latrine. And then that can go into different ways. So it could go as mixed waste to trucking. Let me see if I can expand. There we go. And it shows all the different steps of where it can go in the system. So if you want to look at this specific system more, just use the system diagram and you can see all of those items that come into the system and the different classes associated with them. So let's create an LCA. And first we can do QS dot, let's see if I did it right. Yeah, okay. So if you want to see what goes into the LCA, you can see it has a system, lifetime unit, indicators, an uptime ratio, and then annualized construction. You can set this equal to true or false. If you set it to true, say you have a component that has a different lifetime than the system, it will analyze that cost to the system. If not, then you want to set it equal to false. And it just gives a little more description of all the different things that go into LCA. So if you're ever confused, you can use this code in order to see what it looks like. Now we're going to create or run LCA here. So electricity is the additional impact activity that was not covered in the construction, transportation, or material inputs and waste. So you'll want to add that when initializing this LCA instance. So we have our system, which equals sys. We have a lifetime of 8 years. Our lifetime unit is year. And then we have that electricity we added that wasn't in any of our other classes. And awesome, we have our construction, transportation, stream, and then other, with other being the electricity. So if impacts from other activities change with simulation, you can add them as functions, as so. Let me Some more lines here. So now we added some other impacts. So we have impact of A, impact of B, and you'll see how before our global warming was 2.5, and then our fossil energy consumption was 5 to the 10th power to the 7th. So now we have our others has changed because we added these 2 additional activities that go under others, and then that impacts our total global warming emissions and fossil energy consumption. So we saw that there are updates in our fossil energy consumption values. You can also change it again if you want. So instead of 100, you could change A to 10,000. And as you see here, you can see the change from others to this here. So before it was like 275, now it's 2.52, 10 to the 4th power. So it's pretty large now. And we can also get a detailed breakdown for a specific category. So let's see, we can look at construction. And let me make this a little bigger. You can see all of our different items that are in construction, what SAN unit they are involved in, the quantity, how many, the item ratio, the global warming impact they have, and fossil energy consumption. And so those are all of your construction impact items in your LCA. You can also look at those in your stream. So we have our methane, we have liquid nitrogen, liquid potassium, phosphorus, soluble potassium, soluble nitrogen, soluble phosphorus. And we can see all of our stream items. We want to look at the impacts for, you can specify it to be all, direct emissions, or offset. So let's see what alls looks like. So here are all of them. And then, as I mentioned, and it was in this comment right here, you can look at direct emission and offset. You can see how those differ between all, and then direct emissions, offsets, and then I guess here, I can copy this line of code. So here it looks like we're adding up our direct emissions with the offset. And so it's the sum of the stream, direct emission, and offset. So you can see it added those together, and it's the same or similar to this number up here. And that's because our stream is so tiny that it barely added any more when you compare it to the total of the direct emission and offset. We can also normalize the impacts for a certain stream with the default method by allocating the mass. So we see here the different global warming impact and fossil energy consumption for each of these liquid streams. And these streams are associated with the A13 SAN unit. And if you go back and look at that chart that we pulled up a few minutes ago, you'll see where that SAN unit comes from. We can also allocate it by energy. And see the impacts just from energy consumption. So you see nitrogen doesn't have any, but the liquid phosphorus does. It looks like, yeah, liquid phosphorus is the only one that has any impacts from energy. And then we can sum all those together for that specific SAN unit A13. Yeah, so these are all of our allocated impacts just for the one SAN unit in our total system. And we can also look at impacts associated with a certain unit. So for the unit A2, we can see the global warming potential and the fossil energy consumption just for that unit. And just in case I missed it earlier, before this was all, this was just for global warming. So we were looking at all of the impacts associated with global warming for the A13 SAN unit. Here we're getting all the impacts for both global warming and the fossil energy consumption for this A2 SAN unit in the system. And then after this, you will export all the details as an Excel file and save the report. So thank you for joining me today. I believe that was tutorial 8 on life cycle assessment. Hopefully you learned what an impact indicator is, an impact item, a stream impact item, the construction transportation class, and how to add other activities into your life cycle assessment and simulate your life cycle assessment within QSDsan. If you have any questions, feel free to reach out. This QSDsan is on Pi, GitHub, and there's also Read the Docs, which is my preferred choice of looking at instruction for QSDsan. See you next time.